All right, the last trend that we're going to talk about before we mash everything up, kind of like how it would be on an assessment, is electronegativity. And this is my personal favorite, okay? And it's abbreviated EN. Now, listen to the definition and then listen to the definition, okay? So, the electronegativity is the tendency for an atom to attract electrons to itself when it's chemically combined with another element. Or, as I like to read it, it's the tendency of an atom to attract electrons to itself when it's already chemically combined with another element. How scandalous. It's already bonded to another element, and it's like, oh, hey, where are you? Can you come over here, electrons? I'm not happy in my union. I'm going to try to cheat. Playa gonna play. Woo! All right. So now that we know that electronegativity is basically how much of a player and how much game this whole thing has, now we can put this into perspective. Okay, this is expressed on the Pauling electronegativity scale. And again, our noble gases aren't going to do any kind of bonding to anything. They don't participate in any of these reactions. So we're going to not really talk about them. So instead, what about the rest of the periodic table? Okay, well, the lowest in electronegativity is going to be cesium and francium at a zero point 0.7, and fluorine is going to be the highest at 4.0. So let's take a look at what this looks like. All right, so as you travel down a group, the electronegativity is going to decrease. Why? Think back to the first trend. What are all these atoms doing? These atoms are increasing in size. They are not going to have a very strong nucleus. There's all these layers and all these orbitals. So you're going to see these really, really big atoms there. Are they going to be able to attract electrons? Absolutely not. Okay, the transition metal electronegativities are really not as regular, but you will see that as you travel down, the electronegativities are going to decrease. Okay, they're big. These atoms are not very attractive. But as you travel across, yeah, it's going to increase. Remember, this is where all those small, really strong pooled nucleus, those shrink wrap ones, are going to be located. So very interestingly, you will see exactly this. Okay, so this is the electronegativities of our elements. This is our alkali metals. They are going down. They are getting lower and lower. Poor Frank down here, so low. Frank and cesium are both at this zero point 0.7. But you know who's at a perfect 4.0, like a GPA? That would be fluorine. Notice there's nothing here for group 18. Okay, no electronegativities for the noble gases. Okay, so not only is Frank the largest, Frankenstein is the largest, or my Uncle Frank is the largest. If we're looking at these at GPA, he's also kind of like the lowest in the GPA, which is the electronegativity. Whereas fluorine is going to be the smallest, most uh, pulled in and tight, whatever analogies you want to make here, um, and is going to be the smartest with the perfect 4.0. Okay, nobody is as close to him. Oxygen's the closest with a 3.5, and you'll see that as we travel across, they're going to basically increase. But again, here in the middle of the periodic table, we're not going to really concentrate on them because it's not as um, pronounced. There are those exceptions with like column 6 and 11, what we see with these things like changing. So we're not really going to talk about them. They're very confusing. That's something that you would do in a college class. All right, so in general, electronegativity is going to increase over to the right. All right, for the last time, take out a piece of paper and draw a periodic table. And we're going to draw all the trends. And we're going to see if you can figure out a way to learn this on your own. Push pause, get your paper and pencil, come back. Hey, you're back. All right, so atomic radius is the size of the atom. As we travel down, it is going to increase, and as we travel across, it's going to decrease. So that means that Frankium, Frankenstein, Uncle Frank is the biggest, and little itty bitty helium is going to be the smallest. Ionization energy is the amount of energy it takes to remove an electron. As we travel down, it is going to decrease. It's really easy to steal those electrons from Frank. And as we travel across, it's going to increase. So if we split up our periodic table, you're going to see that the cations are on the left-hand metal side. Okay, electron affinity, as we travel down, the tendency to attract electrons is going to decrease. As we travel across, it's going to increase. So you're going to see the anions, the negatively charged stuff over on the right-hand side, except for our noble gases. Ionization energy, ionic radius, wow, can't talk. Ionic radius as we travel down is going to increase, but as we travel across is going to decrease. So we see a similar trend to our atomic radius. And then lastly, we are going to take electronegativity as we travel down, and we are going to see that decrease over here. Francium is going to be at a 0.7, and as we travel across, we're going to see this increase. So fluorine over here is the perfect 4.0. Okay, so we look at patterns all the time. And in a couple of minutes on the other slide, I'll show you exactly how you can remember these patterns and draw this for your own self. All right, so put these elements in order of increasing electronegativity. Okay, electronegativity is going to decrease as you go down, and it's going to increase as you go across. And I want them in increasing order, which is small to big. So again, carbon, nitrogen, lithium, fluorine, oxygen. So, am I writing this from left to right or right to left? Licnof or Foncli. All right, so take a moment. I want them in increasing order. It increases to the right, so I write it from left to right. So that means lithium, carbon, nitrogen, oxygen, fluorine is the correct answer. And that is electronegativities. Stay tuned, and we're going to mix them all up and have you write them on your own, including a fun little way to remember all your trends.